Today's lesson is over the Pythagorean theorem. So right triangles have one 90-degree or right angle. But right triangles have two legs and one hypotenuse. That's a weird name, hypotenuse. The legs create the right angle, meaning they make the right angle. So here's one of the legs, and here's the other leg. And the hypotenuse is opposite the right angle. So we draw an arrow, and it's pointing to, it is opposite the right angle. So here's a leg, and there's the hypotenuse. Right. So a man named Pythagoras discovered a special relationship between the side lengths of a right triangle. If you create a square from each of these three triangles, the area of the two smaller side lengths, so your hypotenuse is always your longest side, the area of these two squares, so here's a square, and this would be a square, the area of these two would fill up the area of your largest. So when you add these two together, they equal that one right there. And so this is how we came up, he came up with the Pythagorean theorem. A squared plus b squared is equal to c squared. Okay. And you might want to write that. You might want to write that this is the hypotenuse. This is one of the legs. This is one of the legs. And so if you notice, the legs are A and B. And it doesn't matter if this is A or B, or that's A or B, but A and B. And your hypotenuse is always going to be C. So your hypotenuse is your longest side. It is opposite the right angle, and it's always going to be letter C. All right, so now we're going to use the Pythagorean theorem. And please start by writing the Pythagorean theorem on your paper. Right? And when you get the triangle, you're going to draw your right angle, and you're going to make that arrow, and you're going to point to C. And then you're always going to ask yourself, do we know C, or are we looking for C? And in this case, we're looking for C. That means these are A and B, and it doesn't matter which one is which. We'll go ahead and say this is A, and that's B. So instead of writing A, I'm going to write 4 squared. And instead of writing B squared, I'm going to write 3 squared. And since I don't know C, I'm going to drop C squared. Okay, I always want to have these 3 spots filled. And then before I add, I want to actually take those roots, those squares, I mean. So 16 plus 9 equals C squared. And then I want to add those together. They're on the same side of the equal sign, so they just combine them. And that's going to be 25 equals C squared. Notice that my side length is C and not C squared. So I want to get rid of that square. So to get rid of that square, I square root, which cancels it. And since I took the square root of the right side, I take square root of the left side. And the square root of 25 is 5. And my C is the only thing left that drops. And this would be 5 centimeters. Okay. So we're going to do the same thing over here. I'm going to start by writing A squared plus B squared equals C squared. Okay, and then I'm going to make my right angle to see if I'm looking for C or if I know C. And this points to C, which is the side length that I don't know. So I'm looking for C, which means that these can be A and B. And again, it doesn't matter which one is which. So instead of writing A squared, I'm going to write 5 squared. Since I know B is 12, I'm going to write 12 squared. And C squared. Make sure we're dropping those squares on all of those. Okay, and then I've got 25 plus 144, so I actually take those square roots, equals C squared. They're on the same side, so I'm going to go ahead and add those. So 25, I've got 169 equals C squared. And again, I don't want to know what C squared is, I want to know what C is. So to get rid of that square, I square root to cancel, and square root the other side. And the square root of 169 is 13, which is C equals 39 then. C equals 13 then.